everyone, I'm Paula Gilbert, the editor of Connecting Africa, and I'm here at Africa Tech Festival in Cape Town, South Africa. And with me is Prenesh Padayachee, who is the Group Chief Digital Infrastructure Officer at Seacom. Hi, Prenesh.
Hi, Paula. Thanks for having me.
So great to see you. So in September, Seacom announced that you are doing a very big project, Seacom 2.0. So, and then today you were sharing a bit more details around that. So I just wanted to know, what is this new subsea cable system and what is the rationale behind building another one when you guys have been in the industry for so long?
So, Paula, for us, it's pretty simple. Our sort of genesis is building subsea cables. We were the first ones to build a subsea cable on the east coast of Africa. We unlocked a whole bunch of economic development on the east coast of Africa. And as technology has evolved and the African continent has had more bandwidth requirements, we find it necessary to upgrade. So we've upgraded our current system. And if you look at the capacity requirements going forward and you project out to 2030, 2040, 2050, we find that the current cable systems that we have in Africa won't suffice for the requirements of Africa. If you just look at that new cable system, the East African or the Indian Ocean Basin sort of area, the capacity and growth in that area will far outweigh what we have from a cable system. So that's the rationale for it. And we will continue to empower Africa for a digitally connected future. That's kind of our line, and that's what we work on every day.
And then on the technical side, what is so special about this new system? What makes it different? I know this is your wheelhouse.
Yeah, so for us, it is the cable system will be built on new technology that exists today. But I think the big difference is we're trying to build an extremely large cable system. We're trying to build a 48-pair cable system, which doesn't exist today. So that's the first sort of area. We're also looking at where we land in countries in Africa. So you'll find that from a technology perspective, we're starting to look at dual landing stations in multiple areas to reduce the risk of cable cuts, power outages and the likes. And then if you go from the subsea portion into the terrestrial portion, we're also reimagining what you do with cable landing stations. And we're making them become communication hubs of the future, where sort of land, sea, satellite, small edge data centers, all of these things come together. So we're looking at it holistically end to end, not just to solve a subsea problem, but to solve a connectivity problem across Africa.
So tell me a little bit about the landing station and the routes that this new system will take.
So on the east coast of Africa, it'll follow pretty similar routes that we have today, except some of the countries we haven't connected previously. We're looking to go into those countries as well. And then we're looking to go east towards Middle East, India, and then all the way down to Singapore. And then to close all of that out by running a cable system from South Africa all the way to Singapore as well. So we'll have a holistic sort of view of that. Then if I look at the cable landing stations and why we've strategically placed them, and I'll give you a good example of this. So in Kenya, most of the cables today, Kenya land in Mombasa. We're looking to go to a new port north of Mombasa called Lamu, which will then create redundancy in that region. And South Africa, you'll also find that we are moving down cable systems, or moving the cable system down the coast of South Africa as well, to go and then cover the southern part of South Africa as well as the western part, which will then take the cable system all the way around as well.
Is the route a little bit different this time because of previous issues you had with cable problems in places like the Red Sea?
Yeah, absolutely. So I should have touched on that. Apologies. So the route that we're looking at, and if you look at all the cables that go through the Red Sea, typically they come from the east. So the obvious thing to do was to hug the coast of the Middle East, which then at the bottom part of the Red Sea puts the cable squarely into Yemeni waters. And because that's such a short section or narrow section of Red Sea, there's only Yemeni waters and Eritrean waters. So we're building a cable that will hug the African coast. So when we get to that part of the Red Sea, we would be in Eritrean waters rather than Yemeni waters. It'll be one of the few cables. There's one cable that touches that water slightly, but the rest of it doesn't. So we want to be in those sort of waters, which will bring us closer to Africa and then give us a different level of redundancy as well compared to all the other cables. Coupled with that, we also think that by solving this Red Sea issue, we'll unlock a whole bunch of other cable investments that have stalled today, which then adds additional benefit, not just for us as Seacom, but for the industry at large.
Yeah. So when are you planning for this new system to go live, and kind of what happens to Seacom 1.0?
So we're targeting end 2029, early 2030 for phase one, and phase one will be through the Red Sea all the way down to Mombasa and then going across to the Middle East. And then with the old cable system, so that cable system will last us to 2035. And what we'll do is, and we try very hard as well, as the industry involves, that we will want to be responsible citizens in deploying cables. So we will then, after a period of time, that 5-year window will give us sufficient time to migrate traffic from one cable system to the other. It will also give us sufficient time when we retire that cable system to then go and recover it rather than just leaving it on the seabed. So that's the intention of this.
And I mean, this is going to be an expensive project, right? How much money are you putting in? And you're looking for investors, I'm guessing.
Absolutely. So from a project perspective, we estimate the project to be between $1.5 to $2 billion project, purely because of the type of system that we're trying to build, as well as the extent of the system that we're trying to build. So that's the first part of it. And we're going through a number of exercises now on speaking to investors. Current shareholders have bought into the program in any event. We'll speak to DFIs, equity partners, and we're fairly open at this point in time as to what that model will look like. And so what we plan to do sort of early next year, end of first quarter, early second quarter, we'll have an investor day, because we'll have much more concrete sort of evidence, pricing, models and things like that, which we're busy working through now, as to what these investments will look like. So it's not a closed system per se. As much as it's a privately owned cable, we will sell off fibers on the cable, we'll sell off spectrum, so it'll be open for people to put down their own equipment on their own fiber pair while we run the subsea system.
Yeah. Seacom is known as the first private cable system. Why is that still so important? Why do you not want to rather just get into consortium, some of these consortiums that are already there?
So we've looked at this previously. And what we find with consortium models is that it becomes very difficult to make quick decisions in consortiums. And for us, it's absolutely critical that there's quick decision-making power. You'll notice that with the current cable that we have, so when we have a cut on the current cable, we make a decision, we repair the cable. We don't have to go through all the consortium members to figure out if everyone kind of can afford the repair exercise or anything like that. Also coupled, when it comes to technology, we can make a technology decision, move ahead, and people can buy into the technology decision if they believe it or not. We're not going through long, drawn-out processes of management committee meetings after management committee meetings. I'm not saying there's anything wrong with consortium cables, but for us, for an organization that is looking for flexibility and to continue to be as nimble as we have been, we find it necessary to build a cable like that.
Yeah. And Seacom's not in the data center market, but you have quite strong feelings about data center neutrality. So tell me a bit about that and how you approach it.
And it's a deliberate action from us not to be in the data center market, because there's multiple providers out there, and we aren't the specialists in data centers. We come from a subsea background, we know how to run cable systems. So what we're starting to look at there is that we will run the cables into these data centers because we understand the plumbing into data centers. So the data center neutrality theme that we talk about is, it allows us to then connect to any data center out there. It gives our client base the flexibility to pick and choose which data center they want in which region. But the beauty about that is they will be on net with Seacom through that entire process. So for lack of better terminology, they got one neck to wring if something goes wrong, because we provide the plumbing between that. We fully understand plumbing in the internet space, and we'll continue to do that. It'll also then gives us the capability, as we move on technology, to allow large bandwidth speeds in between these data centers. With the advent of AI, data center replication, all of these sort of things, we do realize there's going to be a large bandwidth requirement. So this data center neutrality for us is give our clients or the service providers that we deal with the ability to pick and choose which data center they want to, but take away that burden of how do I get connectivity to that, because the data center is useless to you unless you get connectivity into it. So that's the part that we solve.
And then when it comes to terrestrial fiber, not something you guys have really been in a lot in the past, is there an interest in getting into that space? Are you looking into it?
Yeah. So when it comes to terrestrial fiber, in certain areas we build, and typically we will only build in areas where there's an absolute necessity to build because there aren't other providers. Where there are providers, we tend to use their fiber anyway. But one of the areas that we are looking at from a terrestrial perspective is, and because we've got such a deep understanding of subsea, is take the subsea technology and use it terrestrially. And particularly in Africa, because it's such a tough terrain to work in, where you have huge amounts of vandalism, you have difficult temperatures to work with, repair exercises are tough because the roads infrastructure doesn't exist. So one of the things that we're looking at now quite intensely is take subsea technology, move it onto land. Because what subsea technology does for you is it allows you to power the cable on both ends, and then it allows you to run the system. So if you remove that from subsea and put it on land, you may be able to do the same sort of thing. And then that gives us the ability to be very cost efficient, because maintenance on these cable systems are huge. If we can reduce the maintenance costs, we'll have the ability to terrestrially cover large parts of Africa with using subsea technology, which then takes that subsea cable or the subsea technology into the landlocked countries. We then extend our footprint into those landlocked countries, and that's the idea behind it. It'll reduce our maintenance cost, very different operationally to run it, and we do believe that the technology is available today to do it, and we're starting to run some trials on how we're going to do this and what's the most cost-effective way to do it and things like that.
All right, well, a lot going on for Seacom in the future, but thanks so much for sharing what's happening with Seacom 2.0. So thanks very much to Prenesh Padayachee from Seacom.
Thank you for having me on. I appreciate it.